Yay.
So this is our lab problem 4. What is our H naught?
Rho is equals to 0.
Yeah, rho is equal to 0. What's our H1?
Rho is not equals to
Rho is
0.
not equal to 0. So that's our first step. Our second step is finding our critical value. So how many items do we have? 1, 2, 3, 4, 5, 10? So it means my degrees of freedom is going to be 8. Right? 10 minus 2. Measure at 10 minus 2. Alpha is 0.01. So I'm going to look back on my little sheet here and say, oh, let's see. 0.01, this one here, 8, there we go, 0.765. So I'm going to draw my little eye out there. Negative 0.765, positive 0.765, and shade. And then you're going to put these guys into your calculator, right? List 1, list 2, and then step 3 you're going to do stat, test. If you didn't get it, you better be paying attention. Lin Reg t-test. So anybody didn't finish should be paying attention to this. L1, comma, L2. So then you ended up with a test stat of, Alyssa, what'd you get for your test stat?
0.91357.
Huh?
What? This is your list 1, this is your list 2?
Yeah.
Okay. Okay, or most people probably got 0.307.
Yes.
Okay, no worries. We'll figure that out later. So where does that go in here?
Not guilty zone.
Kind of right around here.
Yeah.
Somewhere between this range, right? 0.307. So is that enough evidence or not?
Nope.
No. Do not
Reject.
reject H naught. If you don't put H naught, you are not going to get credit on the exam. Not full credit at least. You're going to lose some points. H naught. Step 4 is all about H naught. Step 5 is all about your claim. So do I have enough evidence?
No.
No, not enough evidence. 2, and like I said, with these ones, it's almost always going to be a claim of a correlation, so it's going to be H1. So you're going to say support a claim of correlation between, what are these two things?
Age and net
Oh
worth.
yeah, age and wealth. Age and wealth. Good. Okay. I'll give you guys just a minute, check with your neighbors, make sure everybody's good. Okay, we can talk about it after class. Or maybe during the break.
Yeah, that's all I was thinking.
Right. Oh yeah. Oh, you know what? It's kind of my fault. Okay, so it's not really a test stat. I should have put R. So that was where, sorry Alyssa. So yeah, so it wasn't your test stat we're looking for, because you do get a T. It's really your R that you're looking for. Because you're comparing the R to the PPMC table. So if you are all the way down, that's where your R is. So thank you for showing us that confusion, because that is confusing. Okay. Great. Let's go ahead and move on. So again, the hardest things on this exam is figuring out what kind of problem you're working with. Because if you screw that up, that's like 10 points on your exam. There's only 8 problems. So we're going to take about 25, 30 minutes to go over how to figure out what kind of problem you're working with. How to tell if it's a proportion or a mean. A proportion will either have that. So first of all, it's be straight with something. You're always going to have a sample. Always. Every problem. Every problem is always going to have a population. And every problem is always going to have an n, a sample size. So here's the things that are different. You're given an n. If it's a proportion, I'm either going to give you a percentage like that, and by that I don't mean a 95% confidence interval or a 90% confidence interval or a 99% confidence interval. Don't confuse those as percentages. Everybody see what I'm saying? And it will always have, remember, p hat is equal to x over n. So we will give you the x, the n, but we'll give you either the x or the p hat. This case here, 28.6%, is that my p hat or my x?
P hat.
Why? Well, how do you guys know it's my p hat?
Because it
Because it has a percent after it. Does that make sense? If it has a percent after it, it's a p hat, the percent symbol. The other thing is the x is always going to be a whole number with no percent. Make sense? Okay. So right. So don't go trying to put. Yeah, I'm not going to say it. I want people to do it.
Yeah.
All right. So the other ones is see I might give you 14 out of 92. Is this a p hat or is this a x thing?
P hat.
X. Which one's your x?
X.
14 is your x. Which one's your n?
92.
Makes sense? 14 out of 92.
Yes.
Great. Also, how do you know it's a proportion? The word mean, average, or a mean in disguise, like an x bar or a list of numbers, is not there. A mean will always have the words mean or average, or mean in disguise, which would be a list of numbers or x bar. Always. I have to give you the mean in some way.
Yes.
All right, so we're not going to go to that stuff because we already covered those other things last class. How do you know if it's a confidence interval versus a hypothesis test?
It'll say estimated.
Yeah, it'll say estimate or it'll say
Confidence.
confidence interval. Literally will tell you, find the confidence interval.
Sometimes it doesn't say interval. It just says confidence.
Sometimes, right,
99%
occasionally,
confidence.
right, right. And a lot of times when it does that, a lot of times it might be a find n problem. In a
Yes.
special case of the confidence interval. A hypothesis will not say those words, will not say confidence interval or estimate. And also, often, but not always, have words like claim, evidence, or test. It's not a guarantee. All right, so don't forget on exams, on the exam it literally says, show all work. Shashank, what did I just say?
Show all work.
So you need to do that on the exam. Also, it says to get full credit, you have to, for a hypothesis test, show all steps, including drawing a picture. So the problem itself won't say to do that. It says that in the beginning of the test in bold. For confidence intervals, it'll say you have to show, you have to give your margin of error. I think say what the critical value is, but I think margin of error is definitely in there. You have to show your margin of error and obviously the confidence interval itself. All right, so here are the steps here. So your hypotheses, step 1, step 2, find your critical value and draw a picture. Step 3, find the test value, test stat, which includes making a formula with the numbers in the formula, and then you can use stat test in your calculator to find out what that actual number is. Step 4, decide to reject or not reject H naught, and you better say H naught here. And you better not say H naught here in step 5, because that's all about your claim. All right, this is going to be enough evidence or not enough evidence to reject or support your claim, and blah, 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 what your claim is. Yes?
Miss Young,
Yes.
do we have to list the values?
Nope, you don't.
You just have to plug it in the formula?
Yeah, exactly. Yeah. You don't have to actually list them. Thank you. Confidence intervals. So here are the steps. You don't have to do this one, but you do have to, you should find the critical value. Find your error, your margin of error E. That's what that E is, margin of error. And then calculate the interval. And then give it to me in this form. Either this form, right?
Yep.
Comma that form, or in, let's pick this, 0.237.246, or give it to me in this form. 0.237 is less than p is less than 0.246. But it's better to be in one of these two forms. Everybody understand that?
Yes.
Obviously it could be a mu, but if it's a proportion, either way.
And
Yeah.
just to clarify, the CV it just stands for the
Critical zone.
CV that you get, right?
Yeah, CV stands for the critical value. So this
Yeah.
ZCD just means critical value.
Critical value.
Absolutely. Totally. Yeah. Thank you. So this is just your critical value there. Good. So for this case, it would be something like, might be like, mu is less than 24.1 and less than 32, something like that. But somewhere along those lines. It can be either one of those forms. All right, so here, we're going to spend, just like I said, about less than half an hour. We're going to go over these problems. So try with your neighbors, read this problem, try to figure out whether it is a mean or proportion. It's written right here. Mean or proportion, Z or T, test or confidence interval, what the claim is. If it's a hypothesis test, it's confidence interval, there's no claim. And then where it is on the yellow sheet. So take a couple minutes, take 15 seconds with neighbors and try to figure this out.
Okay, so basically, maybe anything.
Hypothesis the one sound for
He really wrote out over zero.
mean,
That's
mean.
Why did he do that?
I don't know. Okay, anyways, so that is mean, which means it's a T distribution.
Wait, what's the claim? The claim is that it's
The claim is that because there's a claim.
What is the
Claim is
the average
average is
Your yellow paper. Yellow paper.
All right, it's a mean or proportion, guys.
Mean.
How do you know?
average? Mean.
Okay, great. Is it a, so is it a Z or a T distribution?
Mean.
Why?
Mean.
Mean Mr. T, good. Means mean T. Is it a hypothesis test or a confidence interval?
Hypothesis test.
How do you know?
Says claims.
Says
Claims.
claim, evidence,
Then reject.
Also, there is no confidence interval or estimate.
Yes.
Okay, so you guys find the claim, figure out the claim.
Mu is
Mu not is
that's the are we
Yeah, the claim is H1. Wait, no.
the H naught is. I think. Claim is H
So,
naught equals.
When I'm asking for the claim, I'm not asking for H naught or H1. I'm just asking for what the claim is. What are they claiming? Okay, so what are they claiming, guys?
Then the average number of infection per week at the hospital in the southern
Okay,
west.
yeah, claims the average is 16.3.
Yep.
How do I write that? How do I write average?
Mu
How do I write is?
equals 16.
Everybody good?
Yes.
Okay, so where on the yellow sheet is this? Upper half or lower half? Upper half where the means are. Okay, left or right?
Right.
Right, where the tests are. Okay, good. Next one.
Confidence interval.
So, actually, you guys are pretty good. Let's do 15 seconds on your own, and then check with your neighbors. All right, check with your neighbors.
X bar. And then
Yeah.
It's
It doesn't mean that
it's mean.
Sorry, it's only that
It's a mean.
Oh, sorry.
Confidence interval. 2 samples.
there's no
Where's it on the yellow sheet?
It's on the top left.
Alright, is it a mean or proportion?
Mean.
How do you know it's a mean?
There's X bar.
It has an X bar. Everyone see that? It's a
Yes.
sneaky way of being a mean. Is it, so is it T or Z?
T.
T, mean Mr. T. Alright, is it a hypothesis test or a confidence interval?
Confidence
I
interval.
did it's a confidence interval.
Confidence
It
interval.
literally says confidence interval and estimate both. You guys see that? So is it one sample or two samples?
2 samples.
Two samples. You guys see that?
Yes.
Are they independent or dependent?
Independent.
Good question. So why don't you guys take 15 seconds with your neighbors and try to figure out if it's independent or dependent?
It has to be.
How do you know? How do you tell the difference?
It's independent.
On our yellow sheet, we don't have dependent.
And it has different population density.
Yeah. Changing one.
Right.
Usually dependent on the same.
Wait, so why? What is your definition? That it
No, if it's yes, if it's dependent. Yes. And
Alright guys, which one is it?
independent.
Why is it independent?
Because there's a different number of samples for each.
Yeah, it's one thing. Sample
then-
sizes are the same.
And then
And they
they
have to be, if they're dependent, I have to give you the whole list of numbers because they have to be matched up.
Yes.
I have to give you all the data and that be matched, the data has to be all matched up.
Yes.
Because remember, you have to subtract them to get their differences and you're going to run a one sample t-test on the differences.
Yes.
So if I don't give you both sets of data paired up, it can't be dependent. Good?
Yes.
All right. Perfect. We're on the yellow sheet. We're going to find this.
top left.
Top left? Yep. And remember, the first row is for one sample. The second row is for two samples.
Yes.
So this will be the second row. Next. 15 seconds on your own without talking.
Yeah.
All right, talk to your neighbors.
Proportions.
One sounds good.
What else? The claim. Awesome song.
The middle.
She might
All right, is it a mean or proportion?
proportion.
How do you know?
Percentage.
Percentage.
It has a percentage. It's not like and that's not like a 95% or 90% or or 80%. All good. Great. Is it a Z or T?
Z.
Z. Why is it a Z?
Easy peasy.
Easy peasy. Right. And then is it a test or a confidence interval?
Test.
How do you know it's a test?
Oh.
Oh, yeah.
And there's a claim.
Claim.
There's a claim. Where's the claim?
Is it that?
Oh yeah. Believes. Does that make sense? Believes. So it's sort of like believes it's less than. So that's sort of it has to kind of go together. The tricky thing is sometimes it's less than, right? Like the number of days you worked is less than 5, and that's part of the question. So you can't just go with, you know what I mean?
Yeah.
So that's the thing that's kind of weird about that. But yeah, if he believes it's less than, then
He's claiming it.
then that's yeah. And also, what else? There's no confidence interval, literally, those words,
Or estimate.
or estimate. Okay, so what, I want to figure out the claim.
P less than, P equals, is less than 20 point.
Why is it a P?
Because of the proportion.
Proportion. P is what?
Less than
than
0.23.
23%, 0.23 or 23%, either one, same thing.
Okay.
Good? All right, great. Where are you gonna find this on your sheet?
Bottom
Bottom right.
right, first
Great.
row.
First row, terrific. Next.
Not first row, but yeah, third row, I guess you would say.
15 seconds on your own, or 20 seconds on your own? So to read it.
One sample.
All right, talk to your neighbors.
It's a proportion.
Well, no, Barry is
Proportion.
Yeah, it's bottom left.
hiring the exit.
Oh, you want to
So I'm in history mode right now.
Which test do you
Oh, yeah, sure, we can do that. All right, so is this a proportion or a mean?
Proportion.
How do you know?
Percentage.
It was a percent and also says proportion, good. Is it a test or a confidence interval?
Confidence
How do you know
interval.
it's a confidence interval? It literally says confidence interval. Is there a question here? No, it says find the confidence interval, so that's definitely a find a confidence interval. Do you guys see what I'm saying? Find N. So then what would we do for this on our calculator? Stat test what? How many samples?
One.
So one prop, one proportion,
Zetas.
the what?
Zetas.
It, interval. So you guys make sense, because it's an interval.
Interval. Sorry. I'm
Yeah.
looking at the wrong thing.
Wow.
So Alyssa, you do realize that all the tests are written on your yellow sheet. Look in the right column, far right column. All right, you guys take 20 seconds and stare at this one.
Proportion. One sample.
All right, so what kind of problem is this?
Hypothesis.
Is it a mean or proportion?
Proportion.
Proportion, how do you know it's a proportion?
Percentages.
Percentage, good, and then is it a hypothesis test or a confidence interval?
Hypothesis.
How do you know?
Claim.
Claim.
The game, there's
Good, evidence, there's rejecting going on.
Yes.
So I would find the claim.
P equals 17%.
Claims that what?
P.
17, they are, right? So the proportion,
P
P,
equals
is
0.17.
1.17. Everybody okay with that part?
Yes.
So then where would you find this? So if you go to your yellow sheet, where would you find this on the yellow sheet?
Right side. Bottom.
Right side on the bottom?
Yes. Right.
So right side on the bottom. And is it going to be one sample or two samples?
One sample.
One sample. So if you look right here, see it says use one prop Z test. We give you all the tests. I give you all the tests for these guys. For confidence intervals, the calculator doesn't really help you that much because I'm still going to make you find the margin of error.
Yes.
So even if you have the confidence interval, you can use it to check, but it doesn't really help you very much because you still have to find the margin of error on your own. Right? So it's less helpful. It's almost harder to do it that way in a sense. and here, all it really gives you is a test stat. You still have to do steps 1, 2, 4, and 5. Yeah.
So for the exam for this, do you want us to like write down the equation and then we can put it in the calculator? Or?
Yes.
Okay.
So all I need to do is put in the numbers. So like z, test stat TS equals 0.243 minus 0.1675 divided by square root of blah 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 blah, and then equals, and then you can use your stat test t test or stat test 1 prop z test to figure out
The
what that actual answer is. It's totally fine.
Cool.
Okay, let's get someone to read this one. This one's nice and long. Shashank, go ahead.
A researcher wishes to see if the average weights of newborn male infants are different from the average weights of newborn female infants. She selects a random sample of 10 male infants and finds the mean weight is 7 pounds 11 ounces, and the standard deviation of the sample is 8 ounces. She selects a random sample of 8 female infants and finds that the mean weight is 7 pounds 4 ounces, and the standard deviation of the sample is 5 ounces. Can it be concluded that at alpha equals 0.05, that the mean weight of the males is different than the mean weight of the females? Assume that the variables are normally distributed.
Okay, so I'm going to take 15 seconds by yourself and try to figure this out. On your own. Need a proportion, Z or T, test your confidence interval. And talk to your neighbors about it.
Me, 2 tests. Hypothesis, 2 sample. Independent.
Yes. And you would find out on the top rock.
So that means it's 2 samples.
It's a 2 samples in which you have to use a
You have to do your
All right, Dennis, is it a mean or a proportion?
Me?
How do you know?
about T test.
I saw it somewhere earlier. Mean weight is 7 pounds, is what I read.
Oh yeah, there you go. Is it a test or a hypothesis? Is it a test or a confidence interval? Haley,
A test,
how do you know?
because it doesn't say confidence interval.
Yeah, doesn't say confidence interval. Good. Everybody all right with where to find the? Okay, so what? How many samples are there? 2 samples. So 2 sample mean, is this dependent or independent? Talk to your neighbors. 5
Independent.
seconds.
Independent because she didn't give us like all of the data
Sample.
values that go together.
What do you guys come up with? Independent or dependent?
Independent.
Independent. Why?
Because there's no data sets.
Yeah, there's a list of data that's matched up. It has to be a list of data and they have to be matched up together to be dependent. So where on your sheet are you going to find this?
Top
Up,
right.
top right,
Top right,
second row.
second row. Top right, second row, and you can see right there, 2 sample t-test is right there. Good? All right. Let's take a break, and then we still have a bunch more I want to do. I want to do maybe like maybe 5 or 6 more of these. But why don't we take a 10-minute break? We'll start back at 48 after, and I'll do another magic trick.
Well, not
Magic.